this video, we'll be discussing one of the questions that came last week in interview preparation marathon, which had the topic logic building. Okay, so basically in this marathon, there will be a weekly contest. Every week there will be a topic from which questions will be there. So there are few contests upcoming, and you can check the complete schedule here and make sure you participate from next time. So let's just go ahead and see how the questions were, and we are going to solve one of the questions. So in this, we are going to solve letter count. So let's just see that. So the question has moved to practice problem. I'll go to practice problem. Okay, so let's just try and first understand the question. After understanding the question, we will try and come up with the logic and then write the code. I'll delete this. Okay, so let's just first try to understand the question line by line. So the question goes as follows. PrepBuddy has created a postal letter counting system for his area postal service. For a postman, it records the information about changes in the number of postal letters after each delivery or pickup. If P is the number of postal letters in the postman's bag before current delivery or pickup, and Q is the number of postal letters in the postman's bag after current delivery or pickup, the system records the change Q minus P for particular delivery or pickup. So this is what is going to be. Let's just see what happens is that P is the number of postal letters in the postman's bag before current delivery or pickup. It could be delivery or pickup both. Q is the number of letters in the bag after current delivery or pickup. The system records the change, that is Q minus P, for that particular delivery or pickup. So again, the sentence is pretty simple. What happens is that P is the number that was there before the delivery, and Q or pickup, and Q is it after that. So Q minus P just gives the change. It could be positive or negative depending upon there is a delivery or pickup. So I think since Q is the number of postal letters after the activity, which means that if Q minus P is negative, it is going to be delivery. If it is positive, it's going to be pickup. Okay, let's just go ahead. To test the postal letter counting system, a postman and delivery or pickup places are chosen. The places are numbered in chronological order from 1 to n. At the end of the day, PrepBuddy has the test information for the place. The postal letter counting system recorded the changes C1, C2, C3, C4, Cn. That is one record for each place. Ci is the record for place I. So there are n places. They are from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, something like that till n. And for every place, there is a change that is recorded, like whether there was a delivery or pickup, depending upon that. Your task is to find the number of possible ways how many postal letters could be in the bag before the first delivery or pickup stop if the bag has capacity X. So basically we are given the capacity as well. So basically we are asked that if the bag has capacity X, and based on the changes that are over here, I have to tell that what are the different ways in which the letters could be there. For that matter, let's say there could be have been possibility that there will be a 1 letter, there will be a 2 letter, there will be 3 letter, there will be 4 letter. So basically these are the 4 possibilities that are there. So I just have to say what are the different possibilities of number of letters that could be there. Now the question is obviously how do I decide what are going to be the different possibilities, what is going to be the input, what is going to be the output. So let's just go ahead and see that as well. We'll see the input-output format, constraints, and the examples. So if we see the input format, first line contains T. This is be my T. It's denoting the number of test cases. For each test case, the first line contains 2 space-separated integers n and x. N is the number of locations or number of delivery pickup. X is the capacity of the bag in which he was having letter initially. Second line contains n space-separated integers, representing recorded sequence C1, C2, C3. So basically these are the changes. So in this case, this is the T, this is going to be my N, and this is the capacity. In this case, this is my C1, this is my C2. In this case, this is N, this is the capacity X, this is C1, C2, C3. We have to see what is going to be the output. The number of possible ways how many postal letters could be in the bag before the first delivery or pickup stop. If the situation is contradictory, we'll be printing 0. So we just have to say that whatsoever first delivery or pickup happened before that, basically what was the initial number of letters. So what is happening here is that there are several possibilities. As we saw that there are several possibilities, we just have to count the number of possibility. We don't have to count the number of letters and print them. the output is going to be the number of possibilities. If there's a possibility that there will be 4 letters, 5 letters, 6 letters, then the output is going to be 3. It's not going to be 4 or 5 or 6. Okay. Now the constant is t lies in range 1 to 10, n is 10 to the power 3, x will be 10 to the power 9 in the range 1 to 10 to the power 9. So we have to ensure that we are handling this particular cases accordingly, and ci will be in the range minus 10 to the power 6 to 10 to the power 6. Okay. Now let's just try and solve this particular test case. So t is the number of test cases. Initially we have 2 changes and we have capacity as 10. So what happened is minus 1, 2 is the change. So initially what happened, that one letter was picked up. Okay, sorry, one letter was delivered. So here one letter is getting delivered, which means I want that at this particular place, I know that there should be at least one letter in the bag. So let's say this is the bag. I want that there should be at least one letter in the bag, because the very first action is pick up, right? Sorry, delivery, right? So there has to be at least one letter. In second case, we are having 2 pickups. Now what is happening here? One letter is already delivered, right? So if you see till here, that if we see, we have one extra letter. Okay, one is delivered. So let's say whatsoever was the capacity of the bag initially, after that one letter was delivered and then 2 letter was pick up, which means that there was one extra letter after this particular activity, right? So we want that whatsoever is the capacity of the box, of the bag, we need that at least one place should be empty. Basically there should be one place for the letter. So we see that the minimum value that we want is 1, so that we can pick up one letter in the beginning, and maximum value that we can have is going to be 9, not more than that. Why? Because in this case, as you can see, if we will have 10 and if we'll try to do a pickup at this particular place, what will happen? We won't be able to do the pickup, right? So what will happen is that we have to have initial value as 1. So we need to have that initially we can have minimum 1 letters and maximum 9 letters. So if this is the case, this case will go ahead. So let's say if there is maximum 9 letters, here 1 letter will be picked up and then 2 letters will be added. There will be no ambiguity. So what are the different possibilities? Different possibilities are 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's going to be, there are going to be 9 possibilities. So the output is going to be 9, right? Let's solve the other test case. So as you can see, other test case is 0, which means that there is some contradictory. We cannot say that, okay, this is how it's going to be. Let's try and solve this. So in this case, we have n is equal to 3. We have capacity as 4, okay? And first change is minus 3, which means that in the bag, we want minimum 3 letters to be there, right? Now the change is minus 4, which means that minus 3, which means that we already delivered 3. Now we are expecting to deliver 4. So which means that we want that initially at least 7 letters should be there in the box, right? Which is not possible because the complete capacity of the letter box is maximum 4, or the letter bag is maximum 4, right? Which means that there is no way that we can have this particular thing working. This is contradictory. So in this case, we will simply print 0. So that is the test case. So that is how the test cases are explained. Make sure, try and solve this question on your own. I have explained you the question. I'll leave you with a hint that solve more test cases. Just try and find the minimum that a letter box should have and maximum. So minimum to a very great extent will depend upon the how many letters are getting delivered, and maximum will be like how many letters are getting picked up, and obviously they'll be talking to each other, right? So just think upon it and try to solve the problem. And in case you are able to solve it, that's great. In case you aren't, you can just come back and see how we solved it. Okay, so now we have seen the question. Let's try and form the logic. Okay, so let's take an example. So let's say we have 8 as the number of changes and 7 is the capacity. So the changes goes as follow. We have minus 5, 0, minus 3, 1, minus 1, 5, 0, 6. Now we said that we want to find minimum and maximum. Basically, what is the minimum of number of letters that should be there to satisfy this particular stuff, and what should be the maximum? And as we have seen that there could be a situation that it is not getting satisfied. In that case, we'll simply print 0, right? So now we know this particular point. If we see other thing, what is this telling me? This is telling me that at this particular point, 5 letters were picked up At this particular point, at this particular point, 5 letters were delivered. Here 3 letters were delivered. So now what we want is that simple thing, that if I want to deliver, then I should have that much of letter in my bag, and if I want to pick up, I should have that much letter in my bag throughout the journey. If I am able to do that, that's great. And whatsoever is the minimum number of letter that is required to be in the bag, and what is the maximum number of letters that could be there in the bag, will give me the possible count. So now let's see that as we keep on going ahead, what is the letter count happening and how the letters are changed. Now let's say we start with delivering 5 letters. So we are delivering 5 letters, which means that we want 5 letters to be there in the box. Here we are neither picking anything nor delivering. So here again, if 5 letters are there in the box, which would, initially it will do. Now here what happens is that we have to deliver 3 more letters. So now what happens is that we already wanted 5 letters. We haven't picked anything in here, which means we want -5 plus -3 letters to be there initially in the box so that the condition is fulfilled. So let's say it becomes -8. We'll see if it is possible or not at the later stage. Let's first see how the situation is going to be. So now, till now, what is happening is that, let's say we have already delivered 8 letters. So now what we need to do is we can pick up 1 letter, right? So let's say I simply pick up 1 letter, then it becomes -7. At this stage, again, let's say I delivered 1 letter, then it becomes -8 again. Now at this stage, again, what happens is I pick up few letters. So what happens? Then the number of letters become -3. Again, here there is nothing, so -3 letters would do. So the number of change in letters since beginning is still going to be -3. And at the end, I have to pick up 3 letters again, right? So now if you see that in this particular case, right, what was the stage at which I decide that, okay, this is the minimum letter that I want in my box, that is for sure. So that was this particular stage. So basically, this is the minimum number of letters that should be there in the bag for sure. Okay. And if we ask what could be the maximum number of letters, then we see that at the end, we see that at a particular point, we want to pick up 3 letters. We want to pick up 3 extra letters apart from the letters that are getting picked up or delivered over here, right? So now in this particular case, what will happen is that since we want that 3 letters has to be picked up extra, okay? So now let's say my minimum is 8. I want at least 8 letters to be there, okay? Let's keep it -8 for now as per the value. So now let's say I want that minimum 8 letters should be there in the box. And what could be the maximum number of letters in the box that we are expecting? Since we have to pick up 3 at particular some point, the max number of letters could be capacity of the box, okay, capacity of the box, which is 7 minus 3. Okay, so maximum we can have 4 letters. We will again see it is possible or not. But as per this particular change, we want that at least minimum 8 letters should be there for the change to happen, and maximum 4 letters should be there. Okay, this is what is we are expecting. And obviously, as we can see that here, first this is going outside the capacity of the box, plus at a particular stage maximum is greater than minimum. So let's just see another example. Okay, so we know that this is something that is not possible. Let's see some other example. So let's say we have 3 and 4. Okay, 3 is the number of changes, 4 is the capacity. So let's say I go like this. We have -2, -1, 0. So in this particular case, again, let's see how the letters are going to be picked up and delivered. So first I deliver 2 letters, which means I want at least 2 letters should be there in the box. Then I want at least, then again a letter is getting delivered, which means I want at least 3 letters to be there in the box. And then there is no pickup happening. Okay, so as you can see that the maximum letters that we are delivering is going to be 3. So our minimum is 3 in this particular case, and maximum is going to be 0. So now if we take this particular thing, that what is going to be the difference? So if you see, the difference is going to be, we are expecting minimum 3 letters to be there, and what will be the maximum letter that we'll be expecting? Maximum letters that we'll be expecting will be capacity minus max. Please note that this is not the maximum we are expecting capacity minus max. So basically, let's say if there is 10 letters, and we want to pick up 3 letters till the end, then maximum this particular thing could have 7, which is 10 minus 3. Similarly, the maximum letter that a box can have is going to be capacity. Let's make it max L, capacity minus max. And if we have to calculate the number of combinations, it's going to be capacity minus max minus min, minus this particular thing. Because let's say if min is 3 and max, minimum number of letters that could be kept is 3, and maximum number of letters that could be kept in 3 kept as 5 in a box, then what is going to be the total number of combination? It is going to be 5 minus 3 plus 1. So why we are doing 1? Because as you can see here, it's going to be 3, 4, 5, right? 3 combinations. But if you do 5 minus 3, it will give you 2. Hence we add 1. Similarly here, what is happening is that this particular capacity minus max is giving me this particular thing, the maximum number of letters that a box should have in the beginning, can have in the beginning, and this min is giving me the minimum number of letters that a box should have in the beginning plus 1. This is going to be my equation that is going to give me the answer, right? Now what is happening here is that if you see that minimum, for us the minimum is going to be negative only. If it is 0, which means that we don't want to pick up anything, which means that we don't want to deliver anything, it is fine that if we have initial 0 letters, right? So what we will do is, we will simply make our equation as capacity minus max plus min. Now what happens is that in this particular case, this particular equation will give you the answer that is going to be less than 0. So now let me just write it down what I said step by step. So what is going to be the pseudocode? First, what we will do is, we will have a variable min and max. So now we are initializing this, we are initializing the value with this, which means that we are assuming that initially we are fine if the number of letters are going to be 0, initial number of letters are 0, minimum number of letters that are there in the bracket 0, and maximum is going to be W, let's say. So we are saying that if this min and this max is 0, which means initially there are no which means the initial combination is that the minimum number of letters a box can have is 0 and maximum it can have is W, which is the capacity. Okay. Now what we do is, we keep on counting we'll traverse the array and we will keep a sum, count of sum. Like the sum is going to be A of I. Now we will keep on updating our minimum and maximum. It's similar, that which is we have as minimum and maximum. So basically our min is going to be, let's keep it mini. Mini is going to be min of sum, comma, min. Okay, it's a mini. And maxi is going to be max of sum, comma, maxi. So in this way, there is never going to be a point that when minimum is positive. When we are saying minimum is positive, that's not going to happen, right? Because when we are taking the delivery, it has to be negative only. It has to be a negative number. So maximum it can have is 0, which means I'm not expecting anything to be there, right? Similarly, maximum is always going to be a positive number. Minimum is going to be a negative number. That is why we are checking that at any point, if there is a situation when minimum is not negative, let's say at a particular point, the sum is going to be positive, then in that case, minimum should remain 0 and maximum should also remain 0. Now let's say I have this particular number. What I'll do is I'll update our W. W is the capacity. I'll subtract maximum and I'll add minimum. Okay, so basically this is going to be giving me the maximum count of letters that a box can have, and this is going to give me the minimum count of letters that a box can have initially. And basically this is going to be a negative number. So what is happening is, this is going to be either -3, -2, -10. So basically this will eventually be a negative number, right? So which we have already seen that this will eventually give me W minus maxi minus min. Okay. So now this is going to be giving me the difference. Now if W is greater than 0, we will simply print W, else what we will do is we'll print 0. Because that means that there is an ambiguity because there is a contradiction in the given changes. Okay, so that's how it's going to be. Let's try and see the code. So this is the code that we have in this particular line. we are having the initialization and declaration of the variables. We are taking n and w as the input. Then we are running a loop n times to take all the changes as input, and we are also meanwhile calculating the sum, and then we are using the sum to get the minimum and maximum as we have discussed. And then what we are doing is we are just subtracting the mx and adding the minimum number, and we are checking that if basically what will happen in this particular line is that whichsoever is greater than 0 will be printed. So that's how the code is going to be. Let's just submit this code and see if we get the answer accepted. So as you can see, the answer is accepted. If you have to write the code in C++, this code is in C++. If you have to write it in C, everything remains the same. It's just that you have to change C into scanf, and obviously you have to change the functions getting used, and obviously you have to change the header files. In case of Java, you'll be using scanner for taking the input, and you'll be making classes. So that's how it's going to be. So there will be basic syntax difference. If you're coding in that particular language, you will understand that. Okay, so that's how this particular question was solved. Make sure you solve more test cases. In this, I'll say the whole crux is to solve test cases. More test cases you solve, better the logical will be coming to you. And once you solve this type of question, then next time if you get any similar kind of question or anything like that, you will be able to use this particular logic.